In this video, we're going to look at decompilers. In a previous video, we talked about installing decompilers as one of our many tools that we want to use for reversing and exploit development. And here, I want to reverse compile or decompile one of the very first programs that we wrote. And this was a buffer overflow program. So here's the original source code. It's fairly basic. We include standard IO, standard lib. We had a function called function, which took a character string and it set a couple of local variables, which we did primarily to demonstrate how things worked with the stack. Created a local buffer, which we then possibly overran with our passed-in parameter. We returned a value, and then our main function didn't do much. It also set some local variables called function, and then exited. So if I was trying to decompile this, here I have the source code, but in many cases that will not be what you have to deal with. So I might want to use a decompiler. Two decompilers that are pretty commonly used in the Windows world are Boomerang and RecStudio. So we'll start with Boomerang. All you need to do is run the Boomerang program, and this is where it happens to be installed for me, and you give it an executable. So here's my buff executable, and that's it. I give it that, it does its thing, and it stores the output. It's telling me the output has been stored in a standard place, in output/buff. Since buff was the name of my executable, it stored my code there. We'll have a look at that code in just a little bit. Before we do that, I'm going to go ahead and use another decompiler. So I'm going to clear my screen here, and I'll use RecStudio. Now, RecStudio is a little bit different. It's very similar in that I need to use the executable, which is recCLI.exe, and I give it my executable once again. And one thing that is different with RecStudio is I need to give it an output location. You're supposed to give it an absolute path. So for whatever reason, if you get it just the file name, it does not seem to store things correctly in your current directory. So that's a little tip there. I'll go ahead and run this. It runs pretty quick on this nice small program. I will go into my editor here, and it's telling me that it's changed these two files, which I already loaded. So if I look at this file, this is the output from Boomerang. You'll notice with these decompilers, there's a whole bunch of extra procedures that you don't remember writing if you have the source code. And that's because there's a lot of overhead with any Windows application. So these are some of those things. You'll also see here a bunch of function prototypes. You'll see there's one for malloc, which is being used, start, which starts out our program. And a lot of these other procedures, it doesn't know what to call them, so it just gives them numbers, proc4, proc8, etc. And then you will see some of these methods are mostly assembly code. And really what that means is that Boomerang does not know what C code corresponds to this. So if you scroll down through here, you'll see here's my malloc function, my start function. There's a few methods here that are being used. For this particular program, it seems as though Boomerang did not do the best of jobs for me in terms of decoding this information and giving me something useful. Again, a lot of the variable names will also have strange names like param1, param2, or register names. Recall from previous videos, we talked about various registers and how they're used for returning values. We also talked about how things are passed on the stack. That's one of the reasons why decompilers tend to use those registers for variable names. If I look at the output from RecStudio, it does look a little better. I still have some of these funny looking functions here, which are part of the overhead of programming in Windows. But if I look, I actually find function. So here's my function being declared. And notice here's my character string that's being passed in. I have a string called v16 that is being set to function. That's my buffer. I have an integer or pointer. It doesn't really know which it is. And you'll notice that here it's actually coming up with a negative number. And the reason for that is the values that I chose to enter there are being interpreted as a negative number and not a positive number. Then we have our call to stir copy, where we copied from A4, which was the parameter passed into this method, and to V4, which is the buffer that we've set up. And we return 1. The next thing we see is our main method. Our main method takes a couple of values and it goes in and it sets main function. It sets that value inside of V8, which is another character string. Once again, I have something called int or pointer. It doesn't know what it's called. And I have this value that's being stored there. Then we have our function call. And function is getting called based on an int or pointer with A8 plus 4. So you might say, well, what's that? If you look at this value, A8, that was argv. That was that array of arguments passed into my function. The rest of this is essentially overhead. These are all the things that are automatically generated for you by the compiler. They look a bit strange and they don't really tell you much.